All right. Okay. So we are talking about now limiting reagent and percentage yield. Okay. So this is the stoichiometry. So we'll look at things, how to find the limiting reagent, how to calculate percentage yield, and also other things. Okay. So let us get started. So when we say limiting reactant, a reagent or reactant, we simply means so this can be a reagent or a reactant. So one of the reaction is used up before the other. So that which will be used up before the other is what we call a limiting reagent. Okay. So the chemical that is used up is called the limiting reactant or reagent, while the other one it is called in excess. So we have two terms now. There is in excess reagent and also a limiting reagent, reactant or reagent. Okay. So suppose we have an equation A plus B to form C. Okay. So in this reaction, there is a point at which actually one product will finish than the other. So that's what we call it will limit us from producing more C. So that's what we mean when we say limiting reagent. So given the example, so in this example, one of these two guys can be a limiting agent, not knowing unless we do some calculations. But just know that they can't be at equal point. Always, there's nothing like that. If they can be at equal, then the reaction won't finish. Why? It will be in equilibrium then. So a limiting reagent or reactant can therefore be defined as a reactant that determines the amount of product to be formed, because if this reaction is to stop, then we won't form more product. You get? So again, it can also be defined that the one you learn out of first during a reaction is what we call a limiting reagent. Okay. Okay. Then when you talk about this limiting reagent, we can also say it's a reactant that makes the least product. So it is the one which actually make you to produce what you produce or what you form. They can be like least, they can be a lot, but it is in charge of actually telling you to say no, I will stop because me I'm in less quantity. Okay, so reactant, it can also be defined as reactant that determines the end of the reaction. So without this, the reaction will continue. So that's what we mean. Okay. So for example, I'll give you even the hint how to find the limiting reagent in a very fast way. So we have this question, example one. What is the maximum mass of sulfur dioxide that can be produced by reaction of 95.6 grams carbon disulfide with 100 grams of oxygen? Okay, so the first thing like that you need to be doing for you to calculate the same limiting agent, let me give you the formula. Suppose we have A plus B. Okay, giving, let's say, C plus D. Okay, so what will happen for you to calculate the limiting agent? I'm giving you the formula now. Okay, the trick. So you find the moles given because the masses will be given. So find the moles of each. You have seen of these two reactants. After doing that, divide by their mole ratio, numbers that sit in front, the coefficient there. So you divide by their coefficient. Then the one which will be less quantity, like the one which will be less after dividing this, then that's a limiting reagent. Very easy and trick. Okay. Okay, so that is it. So demonstrating this one, we'll calculate actually the number of moles, the number of let us do it. What I was saying. Okay, so I had just an issue, but don't worry. Yeah, I had an issue, but we will continue. So we do it now. Okay, so what we are saying is we have disulfide and also oxygen. So we'll get them and find the. So the first thing is we need to find their moles. Okay, the mole of this one will be found as. So we have the mass over the molar mass. Okay, and also for oxygen we have the mass given there as 100. Then also we need to have the molar mass. Okay, so when you do that, you find that the mass given there is 95.6. Okay, then over we have also now the molar mass from the periodic table. You get carbon and also sulfur. Okay, so you find that it is 76.2. So that is 76.2, 76.2 from the periodic table. So you check the molar mass, the total mass of these two guys. Then also for oxygen we have 100. Okay, 100 over 32. This one is 32. Okay, oxygen is 32. Okay, so from there it's oxygen gas O2, you can see there. So it's 32. You multiply 16 times 2 to get that. So the number of moles here that we are getting is 1 point. When you divide that on your calculator, you are finding 1.25 moles. Okay, then the number of moles that you get from here, when you divide that, that will be 3.125. Okay, moles. So these are the moles we are getting. So what we are going to do, divide throughout by their moles. Like I said, they are coefficient moles. Okay, we call them mole ratios. So 1 there we divide throughout by 1 there, and there by 3. Okay, so here we are getting the same thing because we are dividing by 1, 2.5. Then here we are getting 1.04. Okay, so when you judge these two, which one is the smaller here? You find that the smaller one is um the smaller one is what? It's oxygen. Okay, so this is less than that. So this means hence oxygen is the limiting reagent. Okay, so now we know now the limiting reagent. So what we need to do is now, what we are going to do is now, we'll be able to actually find the mass of, remember they said what is the maximum mass of sulfur dioxide that can be produced by the reaction of 95 point. So in short, we are talking about sulfur dioxide, which is here. Which is here. So this is our sulfur dioxide. So it's the one actually that we need to. Okay, so we'll be using this limiting reagent to ratio it with this guy that we have there. Okay, so let us see how we can do this. Okay, I can just lab. Let me just lab here since we have another example there. So I just lab there so that we see what we can do. Okay, we know now oxygen is the limiting reagent with 1 point. So we need to keep this. So we need to keep 1.04 moles. Okay, this is the limiting reagent, but the moles that we had is we are using these are the moles that we got. So this 0.1.04, it was just a trick, by the way. We are getting this mole, which is here, to actually put it in relation with what they have asked us to find. So remember, we have oxygen with the number of moles 3.125. Okay, so these are the number of moles we have, and the oxygen is our limiting reagent. Okay, so we proceed now. So it will be very easy. Like if in the next one, I'll just explain you should try it. Try the next one. Okay. All right. So they are simple as that. Limiting reagent, and you'll be able to find the excess mass, everything like that. So now we have found that this is our limiting reagent. So we'll ratio it with what they have asked us. So have you seen we have oxygen in the ratio of O2 to sulfur dioxide, like that. Okay, so these are the ratio that we have. So what do we do then? What we are going to do is we'll say we'll bring what we call more ratios. There are more ratios. We want to find the mass of this one, then we just need to find the moles of this one, then of sulfur dioxide, then we'll be able to find its mass, because they're asking what is the mass, maximum mass. So what we do is we have more ratio. This we have 3, so these are the more ratio. Here we have 2. Then we bring now this side where these are moles, by the way. Then we bring the 3.12 more of oxygen. So 3.125 moles of oxygen to the one we are looking for, sulfur dioxide. So we cross multiply like that. So say 3x is equals to 2 times 3.125 moles. So you divide throughout, okay? So this is moles. Divide throughout by 3. So x will be equal to, so x will be equal to 2.08 moles. You punch that on your calculator, you find that is 2.0. Have you seen how simple it can be? Always use these mole ratios, okay, to actually associate with what they have asked you, or ratio it. So from there, we have this is the number of moles, and we know how to find the mass from the number of moles is given as mass over molar mass. Okay, so this means that we cross multiply. This mass will be mass is equal to the number of moles times the molar mass of that given molecule. So the mole given now is 2 point, we have found is 2.08 times the molar mass of sulfur dioxide. If you do that on your periodic table, you do this there 16 times 2, then sulfur there. Okay, you do that, then you'll be able to find your mass as 64. Okay, so once you do that, the mass that you are going to get is 133 when you multiply that. So 1.3 grams of sulfur dioxide will be produced. By the way, this is a capital letter. Okay. Okay, so that will be produced. So that's the math. That's how you can approach this. Always just know the limiting agent between the two. Then leave up, get the more ratios like that. Then get the more ratios, bring them here. Then bring the moles of the other guy, which is the limiting agent. Then cross, you'll be able to find the moles of this one. Then after that, find the mass, which is actually the mass they have asked you. That is it, as simple as that. Let's go to the next one. So that is it about this limiting agent. Okay. So we have another question here. What mass of carbon dioxide could be formed by the reacting of 8 point grams with 48 point grams of oxygen? What mass of excess reagent will be left? So there are two questions. What mass of carbon dioxide? So this will be found by like what we have just done on top. Then again, they're asking what mass of the excess reagent will be left over. So again, we are talking about the mass of this guy, I mean the mass of n of these two, that will be left over. So like pay attention, we'll be able to do it properly. So we continue the way we started. Please, we find their moles now. So I won't even light them. So I'll say the mass over molar mass. Even here, the mass over molar mass. Right? So here we have the mass given of CH, it is CH4, which is methane. It is 8, okay, 8. So we have 8, the CH 8.0. Let me just say 8 or 8.0, anyway, no problem. Then from there, the molar mass of sulfur, if you do this, you find that that is 12. Then this is 4 from 1 of hydrogen. So I'm using this, not advanced molar mass. So I'm getting 1 there, I'm getting 12 there. So 12 times 4, I mean 1 times 4, then 12 times 1. So in short, it's giving me 16. Okay, the molar mass. You know how to calculate this. So you say that is 16. Then for oxygen, we have 48. Okay, so we have 48 for oxygen. Then that means we divide throughout by what is oxygen is 32, right? So this is always 32, just like in the previous one. So you find the moles, this will be 0.5 because that's same as half. Then this will be 0. For oxygen, you divide the 48 divided by 32, that will be 0.75. Okay. So anyway, no need of me writing moles like that. Okay. Then you divide throughout by their coefficient moles, please. So once we divide throughout by their coefficient, so you find that we have 0.5 divided by 1, it will be still 0.5. Then this one will divide through by 2 because that's a coefficient there. Okay. So once we divide by 2 that one, what are we getting? Divide um divide this one by 2. What are we getting? Someone with a calculator. Let me just, where did I put my calculator? I've really made a mistake here. You have punched it. When you divide this one, it's not, it should be 1 point something. Okay. So when you divide 48 divided by 32, it can give you 0. So when you divide this one, 48 divided by 32, that will give you 1.5. Okay. Then 1.5 moles is the one you're getting. Then divide throughout by, let me punch. We divide throughout by the mole ratio now, the coefficient ratio, which is 2. Okay, here we divide by 1. So when divide by 2, that will give you 0.75. So when you look at these two numbers, which one is small? You definitely tell that this one is the limiting agent. So CH4 is the limiting agent. So we actually less the case. So CH4 is the limiting reagent. Okay. So since this is the limiting agent, the its mole is 0.5 we have there. So it has a mole of 0.5 moles. So this one is just for a part of trick. Don't take these moles. These ones, they are just there to actually show you, compare which one has a smaller. Okay, so now that we know how to find, we have now seen how to find the same molar mass. I mean the limiting agent. So we'll be able now to find the carbon dioxide because we'll refer it with the limiting agent. So what we do is we get CH4, okay, to our ratio it with the carbon dioxide. They're in the ratio of 1 to 1. So you put their more ratios there like that. They are having one coefficient. So you put them like that. Then from there, what do you do then? From there, you bring now the more of who? The limiting agent. You have seen the goal is to look for the mass of this carbon dioxide. By getting the more, then we'll be able to find the mass. So we'll say 0.5. Okay, 0.5 is the limiting agent more. So then I'll say here it's x. Okay, you cross multiply like that, then that will be just still the same, 0.5. We know how to find the mass now. The mass is given first from the equation of mole. We are saying now, okay, the equation of mole, we are saying we have mole is equals to mass over molar mass. Then that means we are finding this, that will be mass is equals to mole times the molar mass. Okay, so that means the mole we have is 0.5 or same as 1 or half times the mass of carbon dioxide. Now what is the mass of carbon dioxide? What is the mass of carbon dioxide? Okay, what is the mass of weight? Here we have two things. I've really made a mistake. So here what I'm answering is this question here. There are two questions, by the way. So what I'm answering is this one. I'll come also to this one. Okay, so what mass of this one? So we are referring to the limiting agent and this one. Okay, so I've done everything that is needed. Then now the mass of what I'm looking, carbon dioxide, is the molar mass is actually 44. So when you do that on the periodic table, carbon dioxide 12 then plus 16 times 2, which is 32. 32 plus 12, that is 44. Okay, so that will be 22, right? 22 grams when you punch that on your calculator. So we have answered this question. So the remaining question is this one now. Okay, that was left over. So how do we calculate this one? Again, we'll refer the limiting agent with actually what they have asked us. to say what mass of the excess. So the excess now we have is the the excess we have is what? The excess we have is the um it's the oxygen, right? Because the limiting agent is the CH4. So the excess is the oxygen. So what we are going to do is I'll bring the two CH4 to 2 oxygen. So now the coefficient, the go again is to find the mass. Now, since this one is the one limiting us, is the one which knows the exact amount to be. So that's why I'm ratioing with the same limiting agent, which is this one. So this is in excess, like we defined to say this is in excess, okay? So it's in excess. So what I'm going to do is now it has 2 there. Then the moles of this one is 0.5. Then 2x, okay? So we divide that. So that will be x is equals to 1 when you multiply that, right? That ends there. So 1 moles, okay? So that means now we'll find the mass of this oxygen by saying moles is equals to Mr over, M over Mr. Then that means mass, when you cross multiply like that, mass is equals to N times Mr. Okay. Then from there, what we are going to do is we have the moles now is 1 times what is the Mr of oxygen is 32, right? So the Mr is 32. So this will give us the same mass, which is 32 grams, okay? So this is the mass that was used in the reaction, you get? This is the mass that was used in the reaction relating to the limiting agent. So now what remains the excess. So what mass of the excess reagent will be left over? So the mass that will be left over. So we have this which was used in the reaction, the rest was excess. So we subtract now what was being put, which is 48 minus 32. Okay? Then what remains is excess. Okay? So that actually will give us excess. Excess is equals to 22. Okay, 22 grams will be left over. Not 22. This is 16 when you subtract there. I'm sorry. Okay, when you subtract this, 2 there, 2 there, from there, that will be 16. 16. So 16 will be left. So 16 is a gram, by the way. They were in grams, these guys. So that's how you can handle this one. So 16 excess will be left. So that is it. Then from there now we'll be able to calculate the percentage yield, what it is, and everything like that. Okay. So when you talk about percentage yield, you know, the amount of product produced in a chemical reaction is called yield. You are yielding something, you are harvesting something. That's what we mean here. Okay. Let me just change the color. So it's what you call yield. Okay, yield something, you produce something. So the theoretical yield is the amount. So we'll find something like a theoretical yield in the formula. So this is the amount you would make if everything went perfect in your reaction or experiment. Okay, this is what is calculated from the balance equation. So from the balance equation, you are calculating the theoretical yield. Theoretical just from your theory part. You are just lighting, not from practical. No. So we have practical and theoretical. So the practical is always given. So the actual yield or the practical yield or the experimental yield is what is obtained during the actual. The word is actual experiment. So you find that they have already calculated everything for you. So it's just a matter of actually comparing in the percentage form. So the percentage yield, that value you get after putting in a ratio of percentage, indicate what percentage of desired product is obtained. So what you get is actually the desired product that you can actually get from the actual experiment. So it is given by the formula. The percentage yield is given by the experimental yield times 100%, 100, which is the percent. Then theoretical is what you calculate. The experimental or actual yield is actually what is given. They will always give you, this one is always a true value. It was already calculated to say, let's say the room temperature is 27. So this one, they always tell you, but what you calculate, let's say, is 23. So you need actually to do that find the percentage of the desired. So what you calculate that percentage value is what you call the desired product to be obtained. Okay, so that's what we mean when we say we just compare what we have. So we have an example here. It was found that 133.5 grams of sulfur dioxide could be formed from the reactants if in an experiment, if in an experiment 130.0 grams of sulfur dioxide is produced. So in an experiment, so this is the actual experiment you have seen, experimental yield. Okay, so what is the percentage yield? Okay, solution by alpha, it's alpha. Then we have the formula like we gave at first, experimental, which is the actual, or the experimental, actual, or the recorded value that they already know. So over the theoretical, the theory part you are doing from the balanced chemical equation, just that there's no balanced chemical equation, but I'll demonstrate if we find more examples. So from there, we just a matter of substituting. Remember, they said the theoretical part, let me do this. We have the theoretical part there. Okay, so listen. So we have 133 grams could be formed from the reactant. So this was the part of experiment. Then this was the actual one. Okay. So it's just a matter of substituting. So we put 130 on the experimental there because that's what was produced in the reaction. Okay. Then we have also 133.5. Okay. So 130.0 was the actual, the experimental value. Brother. Okay. So that means that the yield will be 130, which is the experimental, then over the theoretical part, which was produced in the reaction. So 133. So that will give us 74. I mean 77, 97.4. I'm sorry, I'm very fast. So that will give you you get that 97.4 grams. So we try this as well. So I'll just tell you what to do there. I'll just tell you what to do there. So here, what do we do? Ammonia is produced by the following reaction: nitrogen and hydrogen gas to give ammonia. By the way, I was supposed to write 3 there. Really made a mistake. So, what mass, in fact, it's not balanced, by the way. So, we need to balance this reaction, this equation. Okay, it's not balanced. So, we need to actually have the actual plus hydrogen like that, then giving us ammonia like that. So we can see now we need to put something like here we'll put 2. We can put 2 there. We have 6 hydrogen, so here we'll put 3. Okay, so that the equation will be balanced now. So now I'll give you just a hint on how to approach this, otherwise you do it. Ammonia is produced by the following reaction. Try. This is the reaction now. What mass of ammonia could be produced from the mix of 100 grams and 500 grams of this one of nitrogen and 5 grams of H2? How much an reactant material remains? It's still just the same like of the previous. So what you do, you first calculate the limiting agent between the two. Okay, given the masses, those masses. So calculate the limiting agent. You say their mass over the molar mass of each, then divide by their mole ratios, then you'll be able to see which one is more. Then that will be your limiting agent. After you find that limiting agent, then you will refight now the same limiting agent you have found, refight with the ammonia part. Okay, 2 ammonia, I mean like that. Okay, so from there then you put the mole ratios. I don't know which will be the limiting agent. Put the mole ratios like that, then bring the moles of the limiting agent, then find the moles of ammonia, then find the mass of ammonia. Okay, so you are now answering what mass of ammonia could be produced. So you are answering because yes, you answer the amount of mass to be produced through the limiting agent reference. So how much an reacted material remains? So you look at the excess between the two. once you find the excess, again refer it, again associate it with the limiting agent, then find again the moles of it, then find its mass, then come and subtract from its given mass. Then that will be your mass in excess. So hope that is clear. Try it, please. Try. Okay. Even this one, I'll just explain, give you a hint. Calcium carbonate is decomposed by heating. It is being decomposed like that. What is the theoretical yield? So theoretical yield is actually the yield that you get. Okay. So this one is somehow tricky because I haven't explained it, but I'll give you the hint. Okay. So what we do is calcium carbonate is decomposed by the heating. So what we are going to get is, the question is, what is the theoretical yield of calcium carbonate? You have seen they're talking about this one now. Grams when 24.8 grams of calcium carbonate it decomposes. So here we already have, this is our limiting agent. So it's just a matter of referring this and this. You have seen? So we'll get the calcium carbonate to calcium oxide like that. So you find the moles of calcium carbonate. So you say we have the mole ratio is what? 1 to 1. Okay. The mole ratio is to what? Remember, the goal is to find the mass of this one after getting just its mole. So the mole ratio is in that way. So what I'm going to do is I'll get the moles now of calcium carbonate by saying 24.8 divided by, it's 100 by the way, the molar mass of calcium carbonate. Then you say, you find something like I don't know what you get. Let's say you get something, a value. Okay. Then this value now, let's say is 2.6, whatever. Yeah. Okay. So then from there, you refer now, you find the x moles of this guy. So after finding the moles of this guy, you find the moles, let's say is 2.6. Okay. Moles. I'm just giving an example. Then this number of moles now, to find the mass now, what is the theoretical yield of carbon? So we are trying to find the mass of that. So what we have the moles there. So you say the number of moles times the mass. You'll be able to find the theoretical yield of carbon dioxide. That's a mass, the yield of carbon dioxide. I mean calcium oxide from the carbonate like that. So that's how you find it. Then what is the, when this is done in the lab, one, I mean 13.1 grams of calcium oxide is produced. What is the percentage yield of this reaction? Remember, we are from just finding the mass of this calcium oxide. So what you do is now they have given you the actual value. This is the one which was done in the lab. So it is actual, not what you calculate. So this is actual in the lab. So now the experimental part you have already done, you have already calculated the mass here. I've already demonstrated how you can do it. So you just now apply the percentage yield formula. Percentage yield is equal to the actual or the experimental over the theoretical, the one you calculate, then times 100. Okay. Then from there you say the actual is the 13.1. I don't know what you find there. Then you can put there and then times 100. You find the percentage. That's how simple it can be. Okay. Pay attention to this question. Very important for you guys who's actually the owner of these lecture notes. Okay. So that's actually marks the end of our presentation. Okay. Thank you very much.